Assalamualaikum and hi. Welcome to Pre-LEPAK Chapter 7. So as usual, we're going to answer a few questions. So let's go through the first one. An object of 4.0 cm high is spaced 15.0 cm from a convex mirror of focal length 5.0 cm. So before we go through our questions, let's list down our information. It says here that the object height is 4.0 centimeter. So HO is 4.0 centimeter and our object distance is 15.0 centimeter. So our U is 15.0 centimeter and the focal length is 5.0 centimeter. So RF is 5.0 centimeter. And it says here that the mirror is a convex mirror, and we know for this type of mirror it curves outward. I've drawn the image of the mirror over here, and this part, as you can see, is curving outward. For this case, on the left side of this mirror is the front of the mirror, and the right side is behind or at the back of the mirror. And over here at the back of the mirror, we will have F, which is the focal length, and C, which is the center of curvature. The center of the curvature C is the center of the mirror. This is because if we imagine the mirror as a circle, a big circle, so the C is the center of the mirror. So any point from the circle to the center C is a radius. So any point here is a radius. So from here, from this, the mirror, to C is the radius. And focal length here is half the radius of the curvature. So F here is R, which is the radius, over 2. And that's why F and C is at the back of the mirror. So now let's solve question 1. But before that, let me erase some part of this. So right, question 1 asks us to determine the position of the image from the mirror. In order to determine the position of the image, we're going to find V, which is the image distance. And to find the image distance, we're going to use the mirror equation, which is equals to 1 over F equals to 1U plus 1 over V. So before we can use this equation, we have to determine the sign convention for U and F over here. In order to do that, we're going to use the table over here. As shown in this table, you can see that if the object distance is in the same side as the incident ray, the value for U is going to be positive. Well, if the image distance, the focal length, and the radius is at the same side as the reflected or the refracted ray, it is going to be positive, and if it's opposite, it's going to be negative. Let's assume that our object is in front of the mirror. So this is in front just now. This is the back. So the incident ray will be over here. And the reflected ray if we label our object distance, will be over here. And as you can see here, the object distance and the incident ray is in the same side. So our object will be a positive value. Well, as you can see, the focal length is at the back of the mirror, while the reflected ray is at the front, so it is on the opposite side. So the value or the sign convention for the focal length here is negative. So now, since we have determined the sign convention for U and F, let's plug in our information. So 1 over minus 5.0 equals to 1 over positive 15.0 plus 1 over V. Rearrange to get B, we will get minus 3.75 centimeter. The negative value over here shows that the image form is virtual. So what it means by a virtual image is that the image is formed at the back of the mirror. So the image is formed somewhere over here at the back of the mirror, and it is on the opposite side from the object. Now let's go through the second question. The second question asks us to find the magnification of the image. So in order to find the magnification of the image, we're going to use the magnification equation, which is the ratio of the image distance over the object distance, and there's going to be a minus in front. So since we have our value over here, we can just plug it in. And we will get 0.25. And there's no unit here. Since our value of the magnification is less than 1, we can say that this magnification is diminished. If it's more than 1, it is enlarged. So the image form here is diminished, which means it is smaller than the object. So now let's go through the third question. The third question over here asks us to find the height of the image. So in order to find the height of the image, we're going to use again the magnification equation, where the magnification here is the ratio of the image distance over, the height of the image over the height of the object. So M, capital M, H, I, which is the height of the object over the height of the image over the height of the object. And we also know that the magnification is equals to the ratio of the image distance over the object distance, and there's a minus in front. So we're going to use this part of the equation to find our height of the image. So let's plug in our numbers. So let's rearrange to get HI, and we will get 1.0 centimeter. So now the last question in A is, it asks us the characteristic of the image. From the first question, we found out that the image form is virtual. So the image is formed at the back of the mirror, which is on the right side, which is opposite from the object. And we know that the image form, any virtual image that form is upright. This is shown from the magnification, as you can see here. Since our value, as you can see here, since our value is a negative, our value for V is a negative, when we plug it in the magnification equation over here, we will get the magnification to be a positive value, showing that the image form is upright. So let's say if the magnification that we get is a negative value, it shows that the image form is inverted. So we can write down image form is virtual, upright, and another characteristic is it is diminished. The image form is smaller because the magnification is less than 1. Now, since we are done with question